All right. Hello. So today I'll be talking about the birth and death of our oceans. Let's start with what is an ocean? An ocean is a large body of water that exists between two or more continents. Just so you know, we have five oceans. We have the Pacific, we have the Atlantic, the Indian, the Arctic, and the Southern Ocean. And all of these oceans are on different parts of the timeline as as we're going to talk about the life of an ocean. Some oceans have are in the early juvenile state, while others are more mature and others are dying, and I will get into that. So first, let's talk about tectonic plate boundaries because it's the tectonic plates that dictate the size and the age of our oceans. First, I'll start with the convergent plate boundary right here on the left. So this is when two plates collide, when they converge. So we have three types of this. We have continental continental, which is when the two continental crusts converge. They create mountain ranges like that. Then you have a continental oceanic, where the oceanic will just subduct under and melt back into the mantle. And then you got oceanic oceanic, where when the two oceanic crusts collide, the older oceanic crust will actually submerge, will actually subduct. And the reason for that is because the older oceanic crust is colder, which means it had more time to cool because it was older. And then since it had more time to cool, as things cool, they get denser. So the denser material always subduct under. And when you have two oceanic um, crust converging, it creates an ocean trench, which we see in the West Pacific Ocean in the Mariana Trench, the deepest part on Earth. Now moving on to the another tectonic plate boundary, we have the divergent. A divergent boundary is formed from continental rifts. The continental rift is formed by, well, I'll get into that in a second, but this is basically when the plates, like when the when the ridges keep spewing out magma and basaltic mafic material, and it just separates the two continents. And in here, it creates like an ocean basin. And then here on the right, we have the transform tectonic plate boundary, which I'm not going to talk much about. But let's get into supercontinents. You should know what Pangea is. Pangea is the supercontinent. Supercontinent is when all or the majority of the land masses on Earth are together, forming one massive piece of land known as a supercontinent. We know what Pangea is one of them. That's the most famous one because that's the most recent one. And another one before that is Gondwana. We don't hear much about that because we don't know much about what it looked like. But anyways, so what made Pangea break up is the continental rifts. So if I go back to this, along here in the gray, we had a massive continental rift. So rift formed, which caused the breakup of Pangea. So how these continental rifts form is that the magma will find a thin, weak spot in the continental crust, and it'll just put pressure on it and pressure on it, and then eventually the magma is just going to come up, and then it's just going to keep spreading it, and this is how we got our mid-ocean ridges. And if you look in this video right here, my cursor is, you see the breakup of South America, Africa, and North America. That's due to the Mid-Atlantic Ridge. This is the Mid-Atlantic Ridge right here. What it was, it spewed out lots and lots of magma over the course of the last few 100 million years, and it caused the continents to drift, known as continental drift. So the seafloor spreading caused the breakup of Pangea, and That's how the continents are placed in the way they are today. And the Wilson cycle. Continental rifting is the stage one of the Wilson cycle. Like I said before, it's when the magma finds the weak spot in the ocean, in the continental crust, and it just begins the separation. But now I'm going to go a little deeper into this. So it's stage two is a little bit after the original continental rifting, where you find this first little body of water. This is known as a juvenile ocean. A perfect real world example of this is going to be the Red Sea between Egypt and Saudi Arabia. So the Red Sea is a juvenile ocean. But like in the Red Sea, there lies a divergent plate boundary, which it's it's smaller right now, but it's going to continue. The ocean's like not the ocean. It's not ocean yet, but the sea is smaller now. It's going to continue to get bigger and bigger, and eventually separate Africa and Middle East. And then here, stage three. This is known as a mature ocean. This stage is when the mid ocean ridge has been active for many millions of years and fully separated two or more of the continents. As you can see on the left side here, we have one continent, and then this is another side of a continent that was broken up. Another side of the supercontinent that was broken up, and eventually move on to stage four, where this continent is on the other side of this one, and this one is the other side of this one. Basically, on the other, it's where the ocean on the other side of the world begins to subduct under the old, well, the subduct under the continental crust, and then eventually, as you can see in stage five, they get closer and closer. And in stage six, they finally reach the two ends of the continents finally meet, and they form a mountain range. And then probably asking like, what's going on with the oceanic crust here? Why is it just disappearing? No, it's not disappearing. What's happening is that it's being subducted into the mantle. It's melting in the mantle, and then what the material that's being melted in the mantle is being recycled and used back in stage one and two and three. It's going back into the mid ocean ridges, and that's how the seafloor spreading continues. The material is just being recycled and recycled. That's why the Wilson cycle is called a cycle, because it just keeps going and over, like all over again. Now, how long should we expect these oceans to live? It really depends on the plate boundaries that exist in these oceans. So for example, right here in the Atlantic Ocean, we have the Mid-Atlantic Ridge, which is a divergent plate boundary. As you can see here, this has a very slow spreading rate because there's not a lot of red zone, means there's not a lot of new rock. But here in the East Pacific Ocean, there's lots of red zones, which it's a faster growing ocean. But the ocean's not growing, it's actually shrinking. I'll get to that in a second, but this rock is growing at a very fast rate. But over here, look on the right side of this picture, where it's very, very blue. This is the west side of the Pacific Ocean, where the oceanic crust is very old, which means it's becoming denser, which means that it's going to subduct under this newer oceanic crust right here. Like I said earlier, it's the Mariana Trench, the deepest part on Earth. So this is in the Pacific Ocean is going to continue to subduct itself because the Mid-Atlantic Ridge is forcing North America and South America west. So it's going to end up eventually colliding with Asia and Australia. But we're not going to be allowed to see that. And now back to depth of an ocean. Like I was talking about earlier, when the oceanic crust, the older, denser one will subduct, and then eventually the two continents will meet, form a mountain, and the whole Wilson cycle will just continue over and over again. So I actually made a demo for this. I used a soccer ball and a wet paper towel to help demonstrate the Wilson cycle. I hope you guys enjoy this. Demo time. All right. So now I'm going to demonstrate the Wilson cycle using water, paper towels, and this little soccer ball I got here. Soccer ball represents the Earth, and this paper towel represents the continental crust. Let me just do this. Set this up. Bear with me a second. All right. So just do this so it's easy to rip. So look at this. This is the crust. Let's pretend this is like Pangea, a supercontinent. So here, a continental rift will open up from, like what I was explaining earlier. The magma plume just like finds where the crust is like very thin, and it just pushes up, puts pressure on it, and eventually it makes it separate. Come on. Makes it separate. Oh, right here. Like that. Starts there. And just continues. And then this is what we know as like, oh, let me go back a little bit. So this is the start of the mid-ocean ridge. This is considered a juvenile ocean right here. And then as the plates start to separate more and this ridge starts to produce more basalt, producing more oceanic crust. This is the oceanic crust right here. And these continents, well, it becomes two continents now, start to come together on the other side where this other ocean is. Here, the oceanic crust is sinking under the continental crust, going under, and eventually this mature ocean starts to shrink until these two continents meet again. There's going to be another convergent boundary. So after all the oceanic crust subducts back into the mantle, these continents will combine, forming a mountain range to the continental convergent boundary. Mountain range right there. And now our original ocean right here, the mid-ocean ridge, is now considered, well, a very old ocean because it's massive now. And then the process just keeps continuing. It'll just keep breaking up again and again. And that's why the Wilson cycle is a complete cycle. This happened many times over the course of geologic history. That's my quick demo. That was my demo. I hope you enjoyed that, and thank you for your time.